function, if you take the fx of that, again, fx here is what you call the partial derivative with respect to x. So for convenience, we read this one like fx only so that it's faster to read it. So again, of ab, and you equate that to 0, and also your fy of ab, you equate that to 0. Um, then after that, what you're going to do is to solve um, your AB there. Yeah, that's it. For example, you have this one function f of xy, which is equal to x squared plus y squared minus 2x minus 6y plus 14 is equal to that one. Then you have an fx of fxxy and fyxy. We have this. Okay, for fx, you have derivative of this with respect to x. So that's 2x. Y squared is 0. Derivative of negative 2x is negative 2. The negative 6y and 14 are all zeros because they have no x's there. So the derivative are zeros because they are considered constant. Next, for your fy, derivative of the x squared is 0. 2y is y squared is 2y. Derivative of negative 2x is 0. And negative 6y is negative 6 because there's a y there. And derivative of 14 is 0. So what we're going to do now is to equate this to 0. Um, yeah, this is the definition of your critical point. If you equate that to 0 and you solve a value of x and y there, your x and y there values are now your point AB. Okay? They are now your point AB. So for example, this one, 2x minus 2 is equal to 0. Transfer the negative 2 to the other side. It becomes 2x is equal to 2. Divide 2 both sides. Your x is equal to 1. So we have a 1, x is equal to 1 value. Next to y minus 6 is equal to 0. Then solve the value of the y there. So 2y is equal to positive 6. Then divide 2 both sides. Your y is equal to 3. And we have now 1 point, combination of 1 and 3. So that's only one critical point. We have 1, 3 for our critical points. So this one class is, this process is not actually the uh, official one, but it is showing um, the values here of your x's, and we can show that the minimum is 4. So for this one, we have a second derivative test later that I will teach you. You have to apply that so that we can determine its if it's local minimum or local maximum. So in that way, we are very sure with that one. So here, since we can do completing the square, so we can do this. By the way, some of the functions cannot be formed like this. You cannot form it like completing the square. That is why we use that second derivative test later. So here, x squared minus 2x. So to complete this pair, you had to do plus 1, right? Because if you add 1 there, it's equivalent to x minus 1 squared. So correct? Okay. We do that. Plus 1 here. So we minus 1 here in our 14 because we add 0 here inside your function. If you add here 1, you minus 1 here in the 14 part. Okay. So that we only add 0. So it's still the same with your f of xy. So here we have x squared minus 2x plus 1 and 14 minus 1. Next, for the y squared, the partner is negative 6y, and we can complete this. Y squared minus 6, to complete that, we added 9 here, so plus 9. So 14, we minus that with 9 also. So 14 now is minus 1 and minus 9. So that's minus 10. So 14 minus 10, the answer is 4. Okay, now your x squared minus 2x plus 1 becomes x minus 1 squared. And then your y squared minus 6y plus 9 that we had becomes y minus 3 squared. Now, these two values are squared. So they are all greater than or equal to 0, correct? They're all greater than or equal to 0. So it will never be negative. So if this is 0, the smallest value of your f of xy is 4. That is why f of xy is greater than or equal to 4 for all values of x and y. Okay? Because when you substitute any values of x there and any values of y here, it will be greater than 0. So it will be positive number. There are positive numbers. It will be greater than 4. And that's it. Your f of 1, 3, if you substitute your 1, 3 there, the answer is 4. Because if this is 1 here, this becomes 0. If this is 3 here, this becomes 0. So the answer is 4. Or you substitute it here at the top. Your x is 1, your y is 3 there. The same answer. Your f of 1, 3 is equal to 4. And that is the minimum. So that is a local minimum. Okay? Since f of xy is less than or equal to 4 for all values of your x and y there. So since that is a local minimum and we only have 1 point, in fact, it is considered also the absolute minimum of f. Okay? Because we do not have any other local minimum. Now to see that value, if you are going to graph this function, okay, use your graphing calculator to graph this. So we go here. Um, Desmos graphing calculator. You know what, class? You are so lucky because during your time, you can have this one. When I was studying, we didn't have like this, a graphing calculator. So we are just imagining it, but we didn't actually see the real face of the graph. So we have here x squared plus y squared minus 2x minus 6y plus 14. So look at class the graph. So as you can see, it will go there to infinity at the top, and you have a number here at the tip of that. So we only have one number, which is a local minimum, and this is also an absolute minimum. Okay, and that's it. This is that point. Um, That's it. Your x there is 1, your y there is 3, and your z is 4. And as you can see in the graph, yeah, the 4 must be straight here. Okay? And your x there is value is 1, and the value of your y there is 3. Okay? That's it. That's why it's higher there. Next, find the extreme values of f of xy is equal to y squared minus x squared. So for this one class, the graph looks like this. Okay, so we cannot find something like a tip of a mountain in this graph. So we can find a point here. It is like a point between two mountains, right? So as you can see here, if this is your point, there are some parts of the graph that's located here in the upper part. And this one, there are also parts of that point that the other points are lower to that one. So there are positive values and negative values here. So actually, this point class is not a um not a local maximum and not also a local minimum. Okay, we have a special name for this point here. I will discuss that next slide. So here, find the extreme values of f of xy, y squared minus x squared. When you say extreme values, class, we are finding the absolute maximum or the absolute minimum if it has. Okay. Now, we solve fx first. The derivative of this with respect to x is negative 2x. Equate that to 0. So your x here is 0. Now fy, we have 2y is the derivative of this, right, with respect to y. Equate this to 0, so 2y equals 0. Solve the y there, y is also 0. And we have a critical point 0, 0, and that's the only critical point that we have, the 0, 0 point, which is this point here. Now notice that when you substitute y is equal to 0 here, your f of xy becomes negative x squared, which is less than 0. So this value is negative. However, if your x there is 0, this one is 0, the answer is y squared, right? Your f of xy now becomes y squared, and y squared is positive. So thus, every disk with center 0, 0 contains points where f takes positive values as well as points where f takes negative values. So we have their positive values and negative values of your f of xy. And therefore, your f of 0, 0 can't be an extreme value for f. And so f has no extreme value. So that's the reason why it has no extreme value. But you have their critical point 0, 0. And the name of that point is actually this one, a saddle point. So you can see that f of 0, 0 is maximum in the direction of x-axis, but minimum in the direction of y-axis. So near the origin, the graph has the shape of a saddle. So it looks like a saddle shape, right? And so 0, 0 is called a saddle point of f. So a critical point class, it could be a saddle point or local minimum or a local maximum or an absolute minimum or an absolute maximum. So it depends. Okay, now next, we have second derivative test. So suppose that, okay, this is the test class that I am referring to. You have to use this as always so that we are sure if um, our point AB there is located at a local minimum or a local maximum, or if it is a saddle point. Okay, so we have here, suppose that the second partial derivatives of f are continuous on the disk. So class A, after you're done with fx is equal to AB is equal to 0 and Fy of AB is equal to 0. If you can solve the values of the A and B there, that A and B's are what you call the critical points of F. So what you do next, you substitute it here in the D formula. Your D formula of AB is equal to this one, Fxxab times Fyyab minus Fxy of AB, then this one is squared. Now, if your D is positive, and your fxx is also positive, then f of AB is local minimum. So these two values you are only concerned with the fxx and the d. Next, if the d is positive, then your fxx is negative. So your f of AB there is a local maximum. Okay. Next, if your D is negative, so this one class, if your D now becomes negative, automatically your f of AB is not a local maximum or a local minimum. And that is what you call a saddle point. It's here, note 1. In case letter C there, the point AB is called a saddle point of F. And the graph of F crosses its tangent plane at AB. Okay. Next, another note, if your D becomes 0, so the test gives no information. So f could have a local maximum or local minimum, or could be a saddle point of f. So this is the case when d is equal to 0. Either of the three, is it local maximum, local minimum, or a saddle point? You have to test it again, but not the second derivative test anymore. Maybe all you have to do is to get the points there near with a, b, and then you substitute it in the f. If your AB there is the highest, that is a local maximum. Okay, and that's it. Note 3, this is the shortcut for the D there. Actually, it's determinant. You have there fxx fyy minus f of xy squared. Okay, now you can use this equation, and we are not substituting A and B there. If all of them are constant, you can write this. You can use this if the three values are all constant, because later we have an example that the three values are all constant, and then what we're going to do is to solve the D there, which is using this formula. So no need for you to substitute the A and B there because it will not affect, because all of them are constant. Okay, next we have this one. Find the local maximum and minimum values and saddle points of f of xy, x to the fourth plus y to the fourth minus 4xy plus 1. So here, class, the highest exponent of your x and y is 4. So we are expecting that the highest number possible values for your x there is also 4. So that's just the possible, okay? I didn't say it always be equal to 4. So sometimes it's only 3 that we can solve, 2 or 1 only. It depends on your um, what called this? The polynomial. Okay, depends on this one. Now, what is your fx here? These two terms contains x's, so y to the fourth and 1, the derivative are 0. So derivative of x to the fourth is 4x cubed. Derivative of um, 4xy is negative 4y, correct? Because y there is considered constant. So that's the derivative. Next, fy is equal to, okay, here derivative of this is 0. So derivative of your fy is 4y cubed minus 4x. Derivative of 1 is 0 already. Now you can have this and this one. Now what to do next? We equate them to zeros, right? This one equals 0, this one equals 0. Now both of them has 4 in it. So you can factor out 4, divide 4, all of that, and you have this reduced form. You have the x cubed minus y is equal to 0, and y cubed minus x is equal to 0. Now what are you going to do next is to combine the two equations. Combine the two equations and then solve the values of your x and y there. Okay? Now for the first equation, you can have this. If you transfer the y to the other side, that is x cubed is equal to y. Or y is equal to x cubed, correct? Y is equal to x cubed. Now substitute your y here. Y is equal to x cubed. Then this becomes y here becomes x cubed. So x cubed cubed, that is x to the 9 minus x is equal to 0. Okay, remember that one? X to the 9 minus x is equal to 0. And we have this. Okay, now for the first equation, we have y is equal to x cubed. And substitute your y here. And substitute that into the equation. So x to the 9 minus x. Okay? So it's here. X to the 9 minus x. Now you can factor out x here. So x is equal to x to the 8 minus 1. Now x to the 8 is a perfect square and 1 is a perfect square. So this is difference of two perfect squares. You can factor it out. We can make it x to the fourth minus 1 times x to the fourth plus 1. Correct? Now x to the fourth minus 1 is again perfect squares, x to the fourth and 1. So we can factor this out again. We can make it x times x squared minus 1 times x squared plus 1. Okay? And then x to the fourth plus 1 there. Just copy this. So the factor of this is this 2. By the way, class, you can still factor out this one, x squared minus 1, correct? You can still factor this out to x plus 1 times x minus 1. And then equate them all to zeros. First, x is here. The first factor is x. So x is equal to 0. That's the first real root. Next, you have the roots here in the x squared minus 1. So transfer the minus 1 there to the other side. It becomes positive 1. So x squared is equal to 1. Take the square root both sides. Now, if you take the square root both sides, you have two answers, positive and negative. So your x there is equal to a positive negative square root of 1. And its is 1 and negative 1. Correct? So it's here. Now these two factors here, class, the x squared plus 1 and x to the fourth plus 1, they are the sum of two perfect squares and they do not have um, a real value for the x there. Okay, why? The reason is, for example, you have this x squared plus 1 here. Transfer it to the other side, your x squared is equal now to a negative 1. Now, your x squared is always positive. It will never be equal to a negative 1, right? Now, if you continue to solve that, you take the square root both sides. That's positive and negative square root of negative 1. And square root of negative 1 is error in your calculator. And that is actually an imaginary number I. So here, it is not a real uh, root. We do not have a real roots here for these two factors. So we only have these 3 points. As I have told you, even if it's x to the fourth, we expect 4 values for x, right? But we can only get 3 here and it's fine. Okay? I didn't said we had to get the maximum like 4 points. Now we combine this with your y there. Uh, can you see this? Y is equal to x cubed. You substitute there 0, you substitute 1, you substitute negative 1 there in your x, and you can solve the value of your y there. Now, if your x is 0, your y is also 0. So we have 0, 0 as a point. Next, if this is 1, your x is 1. So 1 cubed, your y is also 1. Now, if this is negative 1 here, you cube it, it's also negative 1. So the partner of negative 1 is also negative 1. So we have 3 points, 0, 0, 1, 1, and negative 1, negative 1. Okay, so we don't know yet if these points are saddle points or um, local minimum or local maximum. Okay, so what to do? Again, we solve the second partial derivatives, fxx, fxy, and fyy. Now go to your fx. Your fx is this. Um, 4x cubed minus 4y. So multiplying 3 here in your fourth. So solve your fxx, get the derivative of this. You have 12x squared, correct? Derivative of this is 0 because it has no x here. This is minus 4y. So 12x squared is the derivative. We have this one. Fxx is 12x squared. Now go to fxy. To solve fxy, go here in your fx and solve this with respect to y. So 4x cubed derivative now is 0. There's no y here. And negative 4 is the derivative of your fxy. That's the answer of your fxy, negative 4. And for fyy, we go here in your our fy. The answer is 1, correct? Derivative of this is 0 already because there is no y in the negative 4x. So you have here 12y squared. Now we substitute in our equate as for what is for d, we have their fxx, fyy minus fxy. Now multiplying fxx and fyy, 12 times 12, it's 144. Then copy x squared, y squared. Next, minus. Substitute here f of xy. We have negative 4 squared. It's 16. So it becomes negative 16 here. Now, we solve the d zero zero. Our critical points are 0, 0, 1, 1, and negative 1. Now, you substitute all the points in your d so that we can solve your d value. So first, 0, 0. If x and y are zeros, this is 0, this is 0. So the first term here becomes 0, so minus 16. The answer is negative 16 for d 0, 0. And what does it mean? If d is negative, here letter C, it is not a local maximum or minimum, and it is a saddle point here by note number 1. Therefore, it is a saddle point. We go back. Okay, it's here. It follows from case C of the second derivative test that the origin, the point zero zero is called origin, right? Is a saddle point. That is, f has no local maximum or minimum at point zero zero. Next, you have here D11. If you substitute 1, 1 here, it's 1. When you square it, it's all 1. So 1, 4, 4 times 1, 1 there. It's always 1 for 4. Minus 16, the answer is 128. And 128 is greater than 0. So since that is positive class, by our second derivative test, you have to test also the fxx value. Correct? It's here. After your D is positive, you check your fxx. Is it positive or negative? Again, if it's positive, local minimum. If xxx is negative, local maximum. So we solve. Fxx is 12x squared. Substituting 1 there, so because only x is there. So 1 squared is 1 times 12, it's 12. So it's positive. So if this is positive class, what are you going to do now? You substitute now your f11. You substitute now your 1, 1 to your f function. Your f function is this, x to the fourth, y to the fourth minus fxy plus 1. So you substitute that in the original equation. And your f11 value becomes negative 1. Now, since your fxx class is positive, both positive, the D and the fxx, it is a local minimum. Okay? It's here. If both are positive, case A, it's local minimum. Okay? Maybe you will say like uh, the F11 is negative 1. Therefore, local minimum because it's negative. No, that's not the reason. The reason why this is a local minimum because both your D and fxx are positive. When you substitute 1 and 1 there in your original function fxy, the answer is negative 1. Next, the D, the last point, we have D negative 1, negative 1. It's positive, 128 the same. And then your fx is the same, it's 12 also. Both are positive class, so this is local minimum. Now then, when you substitute your f there with negative 1 and negative 1, the result is also negative 1. Now this is also a local minimum. So class, both are equivalent to negative 1, local minimum. So what is the absolute minimum? Can you give me the answer in the chat box? Your local minimum are both negative 1. So what is the absolute minimum? Oh, someone left the meeting after I asked. Why? What happened? Hello. So what's the answer? You're all 19 here. No one can give me an answer? Local minimum is negative 1. What is the absolute minimum? Hello, class. The absolute minimum is the lowest one, right? Oh, it's 1 now? 1 is larger than the negative 1. It is not possible for local minimum, for absolute minimum, rather, because the absolute minimum is the lowest part there. And you have two local minimums, negative 1 and negative 1. So what is the absolute minimum? Hello? 0? Oh, 0 is also higher than negative 1. It will never be an absolute minimum. Can you imagine, class, the numbers? The negative 1 is there, lower than your. The absolute minimum is the lowest number. No one can answer it. Hello, please answer now. The one that we solve has two local minimum, and both of them are equal to negative 1, less than negative 1. Um, Another try. Okay, class. I will now tell you. You have the two local minimums, negative 16. No, it's too far. Um, what we solved there is we have a critical value 0, 0, right? The 0, 0 value gives you what value? F of 0, 0. Oh, we have no f of 0, 0 because it is a saddle point, so no need to test that. So we only have 2 points there that we test, and they are both equal to negative 1. Plus, therefore, class, if you imagine it, the local minimum has, the graph is something like this, and the lower part there are all negative 1. So they have the same value. So the answer is the absolute minimum is also negative 1. Okay? Because they have something like they tie uh with that value. Okay? So if you see that in a graph, you will see it later that it has a saddle point, one saddle point at 0, 0, and two local minimum or the absolute minimum because they have the same value at the lower part. Wait, can I See it? Oh, there is no graph of it. So we can graph that using our distance graphing calculator. So for this one class, we will go to the distance graphing calculator. We expect class that there are 2 points there at the lower part. F of xy is equal to x to the fourth plus y to the power of 4. And then after that, we have minus 4xy plus 1. And that's it. This is now class the graph. We just have to rotate it. So as you can see, class, they have two local minimum here. And they tie with the answer, -1. So the lowest class is automatically -1 because they're both there. And so that's the absolute minimum also. Okay. And there's a saddle point there at 0, 0. You cannot clearly see it here if we rotate it. Yeah, but it looks like this two um these two values there, and then the 0, 0 point is here, right? So as you can see, it looks like it's the lower part of the mountain, this one. If you can imagine, like it's a mountain and the 0, 0 is here at this point. It is a saddle point, okay? And that's it. Um, so we're done with this. The question is asking for local maximum and local minimum. We only have local minimum values, -1, and it's also the absolute minimum value. We have no local maximum for this because as you can see there, the graph goes up to infinity. So we cannot find a larger number there on top. Okay. Cannot find the largest there. So no local maximum. And we have one saddle point at this one, right? The saddle point that we have is the 0, 0. Okay, next. Find and classify the critical points of this function, also the highest point of the graph of f. When you say highest point of the graph of f class, we are talking about the absolute maximum there. Okay, so that's it. Next, we have um, first order partial derivatives. So fx of this function, we have this one, and then the fy is this. Now we equate this to 0, the first fx, and then the fy equate that to 0. So what will happen here in the fx? Common term here is 2x, so we factor out 2x, then equate them to 0. And then your fy, 10, 8, 8 here. So common number there is 2. So we can divide all numbers there by 2. So we have there 5x squared minus 4y minus 4y cubed is equal to 0. Now we've partnered them. First, 2x is equal to 0, and we can solve their x is equal to 0. And another for equation 4, we have this 10y minus 5 minus 2x squared is also equal to 0. So we have there two cases. So first, x is equal to 0. You substitute it here in the number 5 equation. Again, you have to combine um, the fourth equation and your fifth equation, right? So here, fx is equal to 0 and fy is equal to 0. This is the result, right? So you have to combine them and then solve the values of your x and y. Okay, so here we can solve many values for x and y. So first we have this one, 2x is equal to 0. We have there 0. Now substitute this in your fifth equation. Now class, if your x here is 0, what will happen? This one will happen. Negative 4y minus 4y cubed. And you can factor out negative 4y here, right? And this will happen if your x there is 0. The equation 5 becomes like this. You can factor out negative 4y, so 1 plus y is equal to 0. Now this is a factor of the two factors here. You equate that to 0. So negative 4y is equal to 0 for the first factor. Divide negative 4 both sides. Your y is 0. Now for the second factor, this is 1 plus y squared. 1 plus y squared equals 0. So transfer 1 to the other side. You have there y squared is equal to negative 1. Oh, you cannot find a value of y there, which is real. Because when you take the square root of that both sides, it becomes a square root of negative 1. And square root of negative 1 class is error in your calculator because it is an imaginary number I. So we cannot solve a value of y in this factor. So we only have y is equal to 0. Partner that with your x is equal to 0. We have a critical point 0, 0. So next case is this. If this is your x now, the value is this equation, this factor, 10y minus 5 minus 2x squared is equal to 0. So in this part here, we compare this with the equation number 5. Now, can you see equation number 5? We have an x squared here. Can you see this? Yes, you can see that. So what to do? We solve x squared here in this equation, and then we substitute it here in the equation number 5, so that equation number 5 now contains only y variables. There are no x's here anymore if we do that, okay? So we solve the x squared in that one. So we have their second case, 10y minus 5 minus 2x squared is equal to 0. Transfer 10y to the other side, transfer 5 there, then divide -2, all the numbers. Then your x squared now is equal to 5y minus 2.5. This is the value of your x squared. Substitute it here in the equation 5. So multiply that with 5. Then minus 4y minus 4y cubed. So here, multiply this by 5, it becomes 25y minus 2.5 times 5, it's 12.5. So minus 4y cubed is equal to 0. And class, actually, in your calculator, no need for you um, to make it like this as a cubic equation. So they simply can make it like this. By the way, your calculator, you can just type this directly in your calculator and it can give you the values of your y there. Okay? So if you want to um, simplify this, you have this value. And then after that, click your calculator and it will give you three values of your y. Y is a negative 2.5452, 0.6468, and 1.8984. So you have there three values of your y. Now you substitute it here in your equation 6. In your equation 6 here, this is x squared. So take the square root of that. So you have this positive and negative square root of 5y minus 2.5. Now you substitute your points there. So first point is negative 2.5452 in your first y here. Now if you substitute it here, the number inside becomes negative. So square root of negative number is not a real value. Therefore, it says here that x has no corresponding real values. Now next, if your y is 0.6468, the result of your x has two values because it has positive negative here, right? Positive and negative 0.8567. Now, if your y, the third point that we had is 1.8984, substitute it here. Your x value is this. So, class 1 value for y here, you have two values for x. It means 2 points. And here, one value for y, and you have two values for x here, 2 points another. So we have there 4 points here. And then plus our 0, 0 critical points. So we have there 5 critical points in total. Okay, so it's here. So we have a total of 5 critical points. Now, class, why they didn't separate the positive and negative here? Because when you substitute it there in your fxx, they have the same value also for d, and the same value for f. So as you can see, you will say something like, oh, why they have the same value in the f? Okay, positive and negative are those values. So expected class that the exponent of your x there in your f, the exponent of your x there are all even number. So when we go back in the original equation, so as you can see here, this is x squared, x to the fourth. So class, if there is an x cube here, an add number of exponent of your x class, all you have to do is you have to separate the 4 points here. Okay? But since they are all even numbers there, it's fine not to separate the positive and negative points. Okay? So we only have something like, it looks like here 3 points only, but they are all 5. Okay? Now for the fxx, we solve fxx. Where can we solve that? Your fx is here. So your fxx should be 20y minus 10 plus 12x squared. Okay, so the book didn't solve that anymore. You have to solve that. You solve also fyy and you solve xxy, fxy, so that you can solve the value of your d there. So what the book did is they solved that separately here, fxx and then the d here without solution. So there, what they call this, you can check them if they are correct. Okay, now for the d there, it's positive for 0 0, and then here it's positive also. Now the fourth and the fifth point, which is this 2 points here. Okay, where did we get this? 0.86 is from here, 0.8567, just round up to two decimal places. And we have there 6468, it's 0.65. Okay, now the d there is negative value. It's a saddle point automatically. Okay, and then they solve the value of f and then the value of ffx also. Now, the other 3 points, d is positive, and both um, fxx are both negative. So since fxx are negative, they are called local maximum, right? And the value of 0 0 is this, and the value of these 2 points are 8.5. Now the question, what is the absolute maximum? What is the absolute maximum? Can you type that in the chat box? We have here two local maximum, and you can see which is higher. So what is the absolute maximum? What's the answer? What is the absolute maximum value? Hello. You can access the slide there. Okay. Oh, now you are now confused if it's the value or the f. Class, please do not be confused that the maximum value, you should get the value of the f there. It should be the value of the f, not the d. Okay, so the answer is 8.5. This is your absolute maximum value, 8.5, not this d here. Okay, the value of the d does matter only to verify if it's a local maximum or local minimum or a saddle point. Okay, that's the use of your d there. The absolute maximum and minimum are found here in the value of your f, not here also in the fxx. Okay, it only is here in the value of your f. So the answer there is 8.5. Okay, this is your absolute maximum. Now if you are going to graph it, you can see that there's a saddle point at 0 0, and the 2 points here are higher than the other points. Do you have a graph? Yeah, we have a graph here. So as you can see, um, in this point, we have what is this? Absolute maximum here at these 2 points, correct? They have the same level because their values are 8.5. And also, as you can see, the 0 0 point is also is a local maximum because it looks like a tip of a mountain here also. And as you can see, if we rotate that, you can find this uh, points here at the lower of this part of the graph. The 2 points here are the saddle points. We have 2 points for the saddle points, right? We have here positive 0.86 0.65, and also the negative 0.86 and 0.65. Two, two for your saddle points here, class. Okay. And for your critical points, the total here is 5. They're all 5. Local maximum, we have 3 points, including the 0, 0. And we also have two absolute maximum points, 2 points that will give the absolute maximum, which is here. So this is the highest point, 8.5. Class, it's asking for the highest points. So if it's asking for the highest points, class, you have to give the coordinate. So it should be 2.64, 1.9, and then the 8.5, including the negative 2.64, 1.9, and 8.5. So you have the 2 points as your highest points. So if it's asking for the absolute maximum value, the answer is only 8.5. But asking for the highest points, you have to give the coordinates. Okay? And that's it. It's here. The absolute maximum value of f is this, approximately 8.5. Okay, next we have this example, shortest distance. Okay, it's 1:53 already. It's time for your break time. I will give you your 10-minute break now.
Teacher, I want to ask, will we have a review before the midterm exam?
Yeah, we will have it after this. And also next class. Our next class is about reviews only
Okay, thank
because
you.
we're done with all the topics already.
Okay, thank you, teacher.
Okay. Then next week, maybe I can still offer you some reviews, but the instruction is only to give you the slides or materials next week. But if you want to meet me and you want me to discuss some examples, yeah, it's fine also. It's fine with me. Okay. So enjoy your break time. Okay, it's time already, so we continue. This one we have finding the shortest distance from a point 10 negative 2 to this plane. X plus 2y plus z is equal to 4. So since this is asking for a shortest distance, so we have to minimize the distance there. So for the distance, the formula is this one. If you have a point there, x, y, z, we let this to be any point there on our plane. Okay. Now, if you have a point there, you have to minus it and then square it. So this is the formula now, x minus 1 here, then squared it, plus y minus 0 or y squared, and then plus z minus the negative 2 there. Minus negative becomes plus, so we have here z plus 2, then squared. Then take the square root of that, and this is now the formula for your distance. Okay, by the way, this for distance formula is if you have 2 points there in with three coordinates. Okay, now next we have this formula, and you have there three variables x, y, z. So what are we going to do there is we solve the z here in our in the plane, the equation of the plane, and then substitute it here so that we only have two variables that we have to solve, and it's easier for us to solve also if we only have two variables. Okay, so first we solve the z there. So z, transfer the x and 2y to the other side. Your z becomes 4 minus x minus 2y. Correct? From this one equation of the plane. Now we substitute this in our z here. We have a plus 2 there. So 4 plus 2 becomes 6. And then copy negative x minus 2y there squared. And this is now your new formula for the d. And we have a square root. Now um, to remove the square root here in this side, we have to square it. So we have d squared. It's equal to this one now with no square root. So this is your d squared. And we let this to be our function, f of xy. And we have to minimize the d here. Okay? Now, after minimizing the d, what are we going to do there is we substitute the values here. Okay, so first we have to get the critical points of our function f of xy, because the critical points will determine if it's local minimum, and we should get that value for the absolute minimum for this one. Okay, so we have here fx and fy, and we solve this one. Our fx is this one first, x minus 1 squared. The derivative of this is 2 times x minus 1 minus the derivative of this is 2 6 minus x minus 2y, and then multiply the derivative of the x here, which is negative 1. That is why it's negative 2 here. Negative 2 times this. And then solving that, you have 4x plus 4y minus 14. So just apply chain rule here if you take the derivative of fx, and then for fy, derivative of y squared is 2y. Derivative of this is 0 because there is no y here. The derivative of this has a y there, so 2 times here, and 2 becomes 1 now. So we have this, and then times derivative of negative 2y. The answer is negative 2, so negative 2 times 2, it becomes negative 4 times this one. And then if you solve that, the answer is 4x plus 10y minus 24 is equal to 0. Now, as you can see here in your fx and fy, you only have um, one exponent for x and y. So what will happen here is we can only solve one value for x and y here. Okay? So type that in your calculator, and your calculators will give you values for your x and y, which are the following. We have here 11 over 6 and 5 over 3. And this is only the critical point that we have. Now we check if this is a local minimum. So your fxx there becomes 4 because it's from here. 4x plus 4y minus 14. Fxx is 4. Fxy, we have 4 also. And fyy is 10, correct? Because this is 10y here. So we have constant values. So again, as I have told you, if all of them are constants, just solve this dxy by this formula, fxx times fyy, so 4 times 4 minus 10 squared. I know, fxx is 4, sorry, fxx is 4, fyy is 10, so this becomes 40. 4 times 10, 40, minus your fxy is 4, square it, it's 16. So 40 minus 16, that is 24, so it's greater than 0. Now your fxx here, class, is always equal to 4. So if you substitute the point here, it's still equal to 4 always. So it's positive. Now d and f are both positive. So by the second derivative test, f has a local minimum at that point. Okay? So since that is a local minimum, and we only have 1 point, it is automatically an absolute minimum. It's here. We can see this local point is actually an absolute minimum. Okay, and that's it. We substitute it now in your d there. This is your d, right? Take the square root again. We use this one. And then substitute there the x and the y that we solve because we have this point. Okay, now you substitute it there, and the results will become like this. You square this, square and square this one, then take the square root. The answer is 5 over 6 square root of 6. Okay, so we have this value, and that is the shortest distance from that point to this plane. Okay, and that's it. Next, this is an additional um, unit vector. Yeah, I told you about this already, how to solve a unit vector. We have there 1 over the absolute value of a times a. And how to get to that value of a here, just take the square root and the squares of the numbers there, right? We have their example, we have there 2I minus j minus 2k. So 2 squared, -1 squared, and then -2 squared. The total here is 4 plus 1 plus 4. It's square root of 9, which is 3. Then divide it here in your vectors. Constant in your vectors here, we have 2, or the 3 is here, so we can make it 1/3 outside here. 1/3 times this, and that's it. We have 2 over 3 minus 1/3 j minus 2 over 3k. By the way, why did I discuss this again? Because the questions there, class, in um, the test contains unit normal vector. Now, if you encounter a unit there, unit vector, which is normal, so that is unit normal vector. The vector that we are going to consider is the vector of the gradient. Okay, and that is your del f. And that's it. Um, we are now in our review, but we will start with this because actually the unit normal vector is, I didn't find it in the book that we are using. And yeah, I just searched for the answer for this one. So this question is from the previous midterm. So we solve this. We have a given z surface here. Then this is your normal unit normal vector. N is equal to ABC. You have the z there, and then there's a point M. So in which n is pointing upward, greater than 90 degrees. So find the value of c there. Your c is found here. This is the last coordinate here. It's okay, coordinate, right? So A, B, C. Find only C value. Okay. Um, so we solve that. First, this is your Z, and your f, x, y, z, transfer them to the other side. It becomes like this: z minus 5 plus 3x squared plus 4y squared. And this is now your f of x, y, z. Now solve the gradient. So the gradient vector is this one, right? Del f, not del. This is your del f. So partial of f with respect to x, partial of f with respect to y, and partial of f with respect to z. So as you can see here, the derivative of your f with respect to x is 6x from this 3x squared, correct? The rest will be zeros because you have no x there. Now your partial of f with respect to y. So take the derivative of the 4y squared. It is 8y. Now for the z, we only have this z here. So the derivative of that is 1. So there's 6x 8y 1. Now we are given 1 point here, a point 1, -2, -4. So your x here is 1, your y is -2, your z is -14. You substitute that in your gradient, but we only have x and y value here. So if you substitute there, your point is 1, -2, -14. So we only use x and y because there is no z here. So that's 1. -2 is your y value. We have here 6, -16, and 1. So this is now your del f. Now to get the unit normal vector, as I have told you, the unit normal vector is solving the del f uh, normal vector, unit vector of your del f. And we have this one, 1 over the absolute value of your del f times your del f. So for the absolute value of your del f, so just square the three numbers there, 6 squared plus -16 squared plus 1 squared. So we have there 36 plus 256 plus 1. So we have there square root of 293, and you divide it here in your del f, right? Because we have there del f divide this. So divide that in the numbers there, and we can solve this. So now your unit normal vector n is, we have this 6 over the square root of 293, -16, and 1 over square root of 93. And this is your A, this is your B, and this is your C here, C component. But we are only, the question is only asking for the C value. So your C is equal to 1 over square root of 93. So if this is your C here, what is the answer here in your choices? Is it A, B, C, or D, or none of the others? Please write answers now in the chat box. What's the answer? Is it A, B, C, or D? By the way, we are now starting our review for midterm, and this is additional information. Well, I will not upload it yet in your LMS because you can see the answers directly now. My goal is to ask you some questions. So, what's the answer there? Oh, I didn't turn on my video. Sorry. So, what's the answer? My God, I show you already the answer. So, what's the answer in the choices? Your C there has a square root. So you have to convert it into decimal. Nah, I will not show it again. Just kidding. Okay, again. My God, why you didn't see it? It's here. Do you remember the value of the C there? No, I will not show it again. So what's the answer? Is it A, B, C, or D? So the answer is letter A, correct. So A, because that is equivalent to 1 over square root of 293. So the answer is A. This is your C value. That's equal to that decimal point, right? Let me see. Can I check it? Because I didn't solve this one also, class. But it's there in the choices. Um, 1 over square root of 293. And that's it, 0.058420. So that's 0.0584. Okay, letter A. Next, you have this question, and a production line is utilizing two different types. Okay, this time, class, I will give you 5 minutes in each question for you to answer, and then you write the answer, the letters there in your choices. there, 2 is equal to this function, 100x 1/3, y to the power 2/3 units. So where x and y represent the operating hours of these two types of machines respectively. So we have here an assumption. Assume that the total operating hours per day for both types of machines must not exceed 17 hours. So calculate the maximum quantity of products. So you are now asking for a maximum value. So we are going to get the absolute maximum here, right? Now, this in this statement, class, assume that the total operating hours per day for both types of the machines must not exceed 17 hours. So it means that x plus y there, because it's both machines there, you have machine x and machine y there. So x plus y is equal to 17. So it will not exceed there, right? So you have that x plus y is equal to 17. And then since we are talking about maximum value class, we have to maximize also the time. It says here must not exceed 17 actually. When you um when you interpret that, it's okay to be less than the 17 value, right? But we are maximizing it, so that is why we take the equal part. So it's x plus y is equal to 17, and you solve the value of the y there. Are you listening? Solve the value of the y. I will give you the hint how to solve this. Solve the value of the y there. So it's 17 minus x, correct? So substitute it here in your q. Your y there becomes 17 minus x in your q here. Then after that, take the derivative, q prime of x. Okay, so after getting the derivative of your q there, you equate that to 0 so that we can get the critical value. If you equate that to 0, you can calculate that in your calculator and it will give you the value of the x, because you replace your y there by 17 minus x already, right? So we only have one variable there now. So you can solve one value for x, then you substitute it here. Y is equal to 17 minus x, right? You substitute your x there and you can get the value of your y. Now, you substitute the value of your x and y here in this equation q, and you can get now the maximum quantity of the products. Okay? So I will give you 5 minutes for this one. Your 5 minutes starts now. Do you have an answer now? Oh, not yet. You still have 1 minute. Okay, pick your letters now. Just guess it if you do not have an answer. C. Only one is answering. Maybe B. Oh, we had now a correct answer. Someone give me the correct answer. It's Nguyen Do Nguyen Hung. Okay. So the answer is letter B. Congratulations. Okay, it's here. Again, what I told you, you have to um, make it that q there, and then we have our constraint. We have x plus y is equal to 17. And as I have told you, you solve the y there. Your y is equal to 17 minus x. And after that, you replace that in your y there in your q. So we have this one. This is now a function with x variables. And now, as I have told you, next step is you have to get the derivative of your care with respect to x. Okay, this is a product of two terms here, so you will apply product rule. Okay, so first we have 17 minus x to the power 2 over 3, and then x to the power of 1/3. So you can write the 100 at the side and just take the derivative of these two numbers here, two variable, two terms here. Okay, so you can make it like x to the 1/3 first times derivative of this plus this one times the derivative of x to the 1/3. But in the solution here, um, they write it here first, this one, and then multiply the derivative of x to the 1/3. Yeah, it's fine. So you can interchange that one, right? So we have here 100 outside. Okay, first they copied the 17 minus x to the 2/3. So multiply the derivative now of x to the 1/3. We have this 1/3 x to the power of negative 2/3. Correct? Because 1/3 you multiply it here, and then the 1/3 minus 1 becomes negative 2 over 3. Correct? Minus. No, it should be plus there, and then x to the power of 2/3. So multiply 17 minus x to the power of 2/3. So multiply 2/3 here. Then 17 minus x to the power of 2/3 minus 1. We have negative 1/3. Now multiplying additional the derivative of the x here, which is negative 1. So instead of having plus here, it will be changed to minus. Okay? Because there's a negative 1 here as your derivative, multiplying it here. And that's it. Now your calculator can solve this automatically. You just equate this to 0, then type everything there like this. Okay, your calculator will give you x is equal to 17 over 3. Please check this. Can you type all of this in your calculator equals 0? Then your calculator should give you an x which is equal to 17 over 3. Please calculate this. Okay. Now, if your x is 17 over 3, as I told you, you substitute it there in your y value, you can get 34 over 3 because 17 minus 17 over 3, we have 34 over 3. Then after that, you substitute these 2 points now are your critical points x, y, and you only have one critical point there. Then you substitute it here, and this is now 8.99. And we are sure that they are um, what they call this a greater number because there is no other value and they are both positive, so the result is positive also, 899.5273, which is letter B. Okay, so that is why B is the correct answer. Now next you have this question, a point M is equal to So you know this already how to solve the derivative with using polar coordinates, right? From your calculus 1. So we have your r0 is equal to, no, this point here is the coordinates of your point M. R0 and pi over 3. Pi over 3 is your value of your phi here. Okay. So we have this constraint like your r sub o must be greater than 0. So it will never be 0 and it will never be negative. Okay? Yeah, because that's radius. So the value of the radius is always positive. So we have this value, x is equal to r cos phi and y is equal to r sine phi. So just substitute it here. Your r be r sub 0 and your phi there is pi over 3. You can solve an x and y there. And then after that, you substitute it here in your x and y, and then you can solve it with your calculator. Now you have to use here r sub 0, right? When you substitute it here, your x has r sub 0 and your y has an r sub 0. So in this equation, you have now all r sub 0. Sorry. Now, in your calculator, you do not have an r sub 0 there. So you can use any variable there like x or y in your calculator. Okay? Just replace it there with x and y. And it will give you a value. So which of that is the value? Is it A, 9 of the others, B, 21, C, 30, D, 25.98, 08, or E is 15? So your timer starts now. Again, I give you already the hint there. What to do? Substitute r sub 0 and pi over 3 here in your x and y. Then you substitute it here in your x and y here. And your calculator can solve that. And that's it. It's easy to do. So maybe like 3 minutes is enough. Just give you 3 minutes for this. This is easy. Okay. Then you write your letters there in the chat box. Okay. Thank you. Okay, are you done? What's your answers? Mm, the first one who answered E is Baoling Nguyen Cook. By the way, class, when I pronounce your name, I'm so sorry if it's not the right pronunciation. Okay, so congratulations. The answer is E there, 15. So we have this. Okay, as I've told you, you just substitute it there in your X and Y. So we have this given. Then your R is R sub O. Your phi there is pi over 3. And cosine of pi over 3 is 1 half. So R sub O times 1 half. Your X there is R sub O over 2. Now for your Y, it's R sub O times sine of pi over 3. The sine of pi over 3 is equivalent to square root of 2 over 2. So your Y there is R sub O square root of 3 over 2. So I've told you, you substitute it there in your X and Y there now. So we have there your X becomes R sub O over 2 minus 15 squared, plus your Y there is R sub O square root of 3 over 2 squared is equal to 225. Now, since your calculator has no R sub O there, so I have told you you can use X there in your variables in your calculator, right? And then your X will give you two values, the 0 and 15 there. And now, since your R sub O is greater than 0, so we have to disregard R sub O is equal to 0 because that doesn't make sense. It's the measurement of the radius and it's 0. So we had to pick the R sub O which is equal to 15. So we have 15 as an answer, letter E. Okay, next. This question is easy for you to do. How many critical points does the function that one have? So what to do here, you solve fx first, then you solve fy first, then equate them to 0, 0. Then solve the value of your x and y. Now get the combination of the points there, and that's your critical points. So your timer starts now. 5 minutes is enough for this. Okay. Now, it has an exponent 6 there, class. You apply chain rule in getting the derivative, getting the fx and fy. Okay. Okay, class time is up. So how to solve the critical points there again? Take fx and fy, right? So we solve the fx. We use chain rule there. So this is actually equal to your fx, right? This is how to write it in another way. Partial of f over partial of x. So the power there is 6. So transfer 6 here, and then this one becomes 5 now in the exponent, and then multiply the derivative of what's inside. The derivative of what's inside here with respect to x, we have 14x squared. Derivative of that is 28x. Now multiply 28x and 6, you got there 168x times this one to the power of 5. Now equate this to 0 after, right? Now next 168 is equal to 0. Then divide 168, divide 168. Your x there is 0. Now the number here, um, we have here, since the exponent is positive, that's positive 5 there. And the number here, class inside, is always positive. So this will never be 0. You have their x squared. So if your x there is negative, you raise it to square, it's positive number. Then plus 7, and then you have their y. So if this number here is negative, you raise it to the 4, it becomes positive. So the whole thing here becomes positive to the power of 5, it becomes a very big number. Okay, so this is greater than or equal to 0, and then this one will equal to 0 only if your x there is 0 and your y is 0. Correct? So that's the only case that this part here will become 0. Okay, so since we solve already and x is equal to 0 here, so we partner that with the value of your uh, fy there. Okay, so we solve a value which is x is equal to 0. Next, for your fy, we have this one, 6 times this. Now multiply the derivative with respect to y. So 4 times 7, you have 28y cubed. And the answer is this, 168y cubed times this one to the power of 5. Now equate the fy to 0, and we have this. Then this first factor is equal to 0. Divide 168. We have y cube is equal to 0. Take the cube root both sides. Your y is equal to 0. So in this one class, we also get y is equal to 0. And again, this factor here is not equal to 0 because, again, the only case that this factor is equal to 0 only when x is 0 and y is 0. And we have that already. Your x is 0 and your y here is 0 also. So we only have one critical point, 0, 0. So the answer is 1. And the answer is letter B there. So who got the first answer? B? Oh, no one answered the question. What's happening with the chat box here? There is an error class with the screen. What happened in the screen here? Oh, I will now go to the chat box. Okay. 4 442 at 242. The first one who get the correct answer is Bao Ling Nguyen Cook. Congratulations. Okay, the answer is letter B, 1. You only have one critical point. Next question. So class, please do not be confused. The question there is asking how many critical points. So it's only one. That's 0.00. Because you see here that the C here is 0. It means that there is no critical points that you can solve. Yeah, because I saw someone type here which is 0. No, it's counting the critical points class. So it's asking the number of critical points, and you only have 1 point there, the point 0, 0. That is why you should answer letter B there, 1. Okay? Do not answer 0 there if the point is 0, 0. Next question. Which function does domain, which function whose domain is enclosed by an ellipse? So an ellipse class looks like an oval. Yeah, it's similar to oval shape. So you can graph the four um, functions there in your Desmos graphing calculator, and please determine which of this four functions are enclosed by an ellipse. I will give you like 3 minutes to do that because this is easy, right? Just use the Desmos calculator, please. Okay, time is up. By the way, the answer here is letter D. And if you try to graph that using our Desmos graphing calculator, square root of 9 minus x squared minus 3y squared. As you can see, this is the face of the graph. And as you can see here, the domain here in your xy plane looks like an ellipse. It's here. The face that he can make it here in the domain looks like an oval shape or an ellipse. That is why the answer there is letter D. Okay? And that's it. Next, select a function fxy whose graph is shown here. And what is the value? Well, what is the equation? Is it A, B, C, or D E there? Now, if you have here, so what are you going to do? do in the class is to get a point here in this um, plane, and then after that you substitute it here. Okay, this is your x, and this is your y, line of y here, and this is your line z. Okay, so what are you going to do there is to get the value of a point. So as you can see here in this point here, this is your z line, right? Your z here is 0. Your z is equivalent to your fxy, correct? Now, what is your x here? This 0 here is straight with the negative 2 in your x axis, correct? This point here. So we have there a negative 2 in the x. Now this point here also is straight here in the negative 2 of your y. So you have there negative 2, and 0. Your x is negative 2, your y is negative 2, your z is 0. Now you substitute it here in your a, b, c, d, e, and that's it. Which of them will satisfy the point, then that's your function. Now, if it will not satisfy that point there, you pick another point in here, okay? That will satisfy the equation. Again, if you find something like two functions here will satisfy that point, negative 2, negative 2, 0. Again, you replace your x there, negative 2, your y is negative 2, your f of xy must be 0. And that's it. So if two functions are correct, so what you do, get another point here, and then substitute in that two functions, which of them will satisfy, then that is your function. That's it. You had 3 minutes to do that. This one is easy. Two, 2 minutes. Yeah, 3 minutes only. 3 minutes. Your timer starts now. Oh, okay. Okay, time is up. What's your answer here? For the second one, the answer there is D. So Kang Hong Fook got the first answer. And now you answered C, A. But C here is none of the others. Why you have there x squared minus y squared? So it's none of the others, and then the right equation is that one, x squared minus y squared. Okay, so let's try that. So the answer is actually C. It's none of the others. So when you substitute here, class, the point negative 2, negative 2, 0, 0 is your f of xy. If this is negative 2 here and this y squared here is negative 2, when you square that, it's 4. So it's 4 here. So 4 minus 4 minus 4. Square root of negative 4 is error in your calculator. It's an imaginary number, 2i there. So next we have B here. For the B, negative 2, negative 2. So negative 4 minus 4, it's a negative 8. It's not equal to 0. So B is wrong. D, we have if this is negative 2, negative 2. When you square them, it's 4 plus 4. So it's 8. So it's not 0 also in the D. So if this is 8 here, so your E here is square root of 8. So it's not 0 also. So the four functions will not satisfy that point, negative 2, negative 2, 0. So we have to pick there none of the others, okay? Someone says x squared minus y squared is the correct one. So if you have their x squared minus y squared, if you substitute their negative 2, the result is 0, correct? Now, how about this point here? In this point here, in the center part, straight with your x is equal to 0. It is straight with negative 4 in your z and straight with negative 2 in your y. So you have there negative 4 for your z. Your x is 0 and your y is negative 2. So when you substitute that in your f of xy is equal to x squared minus y squared there, so your x is 0, square that, 0, minus, when you square the negative 2, you square it, it's 4. So minus 4, yeah, correct. So x squared plus minus y squared is the correct form of the function here. Now to graph that, you have this one, right? You try it. So x squared minus y squared. If the graph is the same, and you will see it like, oh, it's not the same graph. It's not the same, right? By the way, it's the same class. Wait, I will just rotate it. If you have this rotation, look at the form. It's very near with this graph, right? Look at, yeah, that figure is almost the same with this one. I with this one. And that's it. That's probably the answer, x squared minus y squared. And it's not here, so you have to answer the letter C there. Next, you have this one. Select a function f x y whose contour map is shown by this one. And since it's 3:02 already, I can give you first your 10-minute break. Okay, did not answer it yet, but if you can answer it, it's fine. Okay. Okay, it's time already. Um, what's your answer there? No, do not change your answers next time. So the answer is letter E. You have here Duk Nguyen Min. So please answer only one letter next time, okay? So that's it. The answer is letter E there because when you graph that, x squared minus y plus 8, and that is x squared minus y, and then we have there plus 8, x squared minus y plus 8. Look at the graph, the form is this one. And if you get the um, the face of your contour map there, it's look like this. Okay, and that's it. Next, we have number 4 question, and this is the easy yes or no them. Okay, I will give you 5 minutes for this. You evaluate class partial of f with respect to partial of z at point 0, 0, 1. Again, this question is very easy to do. Hoping that you can get the derivative. Okay, time is up. By the way, how did you solve this? Did you solve this by solving the derivative? Okay. This is how to do it, class. Your x there is 0 and your y is 0. You can substitute them first. Your z there is 1. So just the z there will remain. You can do it like this there. It becomes sine 8 and then ln 4 cubed. Then cos of 9 plus 6z to the 7 over z squared. What we did is we substitute there the 0, 0 if you're in your x and y and remaining z there. Okay, because your z has a value there which is equal to 1. Now, what will happen is the sine 8 and ln 4 cube are considered now constant. So you take the derivative with cos here and then over z and you just apply the quotient rule for this quotient rule. Okay, when you go there again, this one now becomes 0. This is 0, 0, 0, 0, 0. So that's it. Sine 8 is here. Then the remaining here is ln 4 cube only. And here, delete this x to the fifth, this one also, and this one we have there z squared in the lower part. And that's it. Now, um, take the derivative of this too, the quotient part. So here, sine 8 ln 4 cube, just write it there at the side because they are constant. So when you take the derivative of this with respect to z there, because it's partial of f over partial of z, right? Now the derivative of z squared is 2z. So I wait. First copy z squared, right? Z squared. Then times derivative of the cosh. Your cosh derivative is sine h of 9 plus 6z to the 7. And then multiply there with 42z to the 6. Correct? Multiplying additional 42z to the 6 there. Minus copy cosh of 9 plus 6z to the 7, and then multiplying the derivative of the denominator there, we have 2z. So over z squared squared, or z to the fourth in the denominator. Now your z is only 1 there because you have here 0, 0, 1. So what will happen here, we have times the z to the 6, it becomes 42 only. So 42 times your sine, right? Times your sine h of 9 plus 6z to the 7. So your z there is 1, right? So z to the 7 becomes 1. So sine h15 minus 2, because you have there 2z. So 2z becomes 2. So minus 2 times your cosh of 15 also divided by your ln 4 cube. And you multiply also sine it there um, at the left side. So we have there sine 8 and then sine 8, then bracket. Again, we have there 42 sine h of 15 minus 2 times cos of 15 over the ln 4 cube. And you will get this value. Now, sometimes your calculator cannot display the 33 there, the point 33. So what are you going to do is to minus your answer. What my other students did to answer this one, they minus the 24279,203 there, and then the answer is point 33. So that is the decimal point. Yeah, because their calculators cannot display all the values there. But if your calculators can display it, it's fine. The answer there is letter B. Okay. Next, we have this one. How many saddle points does that function have? Okay, your 5 minutes starts now. For this one also. How many saddle points? So to get the saddle points, what are you going to do here? Get the fx, get the fy. fy. You solve it. After that, equate them to 0. Then you can get critical points. After that, solve the d. Now to solve the d, you need the fxx, the fxy, and then the fyy there. Right? You remember it? And then substitute it in the equation of your d there. And that's it. Then you can get the saddle points. The saddle points is that if you solve your d there, if the value of your d is negative, then at that point, then that critical point becomes a saddle point. Okay, time is up. Now for the saddle points, you have this one. What to do? Get the critical points first. take fx and fy, and that's equal to this and equal to this one. Now set this to 0 and your fy is 0. Then we only have 1 point here, and x is equal to 5 and y is equal to 7. So this is the only critical point. Now we test if this is a saddle point. Solve fxx, fyy, and then fxy. Solve your d there. Your d is negative. So what will happen? Your critical point is the 5, 7 is a saddle point. Now class, as you can see here, they're all constant. So if you have here a lot of critical points here, for example, there are 5 critical points here, what will happen is, since your d there is fixed, it's always -4 because of these values. They're all constant there. So when you solve it, your d is always a -4. Critical points. Okay? So luckily, only one critical point can we solve here. That is why we only have also one saddle point. But again, if there are too many saddle points here, like 5, and then your d there is always a -4 because they're all constant here, you have also 5 saddle points. Okay? If that's the case. But now there's only one here, so the answer is letter E. So what did you answer there? So Trong Hoen Lam Bao got the first answer, which is E there, right? Um, he wrote there that the D is -4, then the critical point 5, 7. Yeah, and that is also considered a saddle point. So letter E is the answer. Congratulations. Class, no need for you to explain it. Thank you, by the way. Now, next, let's proceed with the next question. How about this? Let f(x,y) be equal to this. Consider this function. Evaluate the partial of g with respect to s, 4, 5. Okay, and that's it. Where is the answer? A, B, C, or D, or E? You have 5 minutes to do this. Your timer starts now. By the way, for our next meeting, we will do something like this. I will show you the question. I will give you 5 minutes to try it, and then after that, we will reveal the answer. Okay? If you have an answer now, please type it there. So only those who got the answer first, I will mention your names. Okay, time is up. You have this functions here, f(x) and fy. It's equal to 2 and 3 here. And then you have your g of ts here. These are the given. So the solution is we let uts there and vts in your f. Okay, this one. That becomes your u, and then this one becomes your v t cube s squared. Now what to do? Using the chain rule, the partial of g over partial of s, we have fx partial of u over partial of s plus fy partial of v over partial of s. Next, this is your partial of u with respect to s. It's negative t squared from here, correct? Because t cube has no s here. So here with respect to s, the answer is negative t squared. And for the v there with respect to s, your v is this. So with respect to s, multiply 2 here. So 2, your t cube there is considered constant. So 2t cube s, correct? So it's here, 2t cube s. Now what to do? Um, your t and s there is 4 and 5 because that's the question. Evaluate the partial of. Okay. So your u of 4, 5, substitute it there in your u function, which is here, t cubed minus st squared. The answer is negative 16. And then your v there, 4, 5, when you substitute there is 1600. So your v there is this, uv, 16, 1600. And that is actually your f there, your fx of negative 16 and 1600. Your fy, they are given. They are here in the question. It's 2 and 3 there. Okay. So that's their value, 2 and 3. So we substitute it here now. The partial of g over partial of s for 5. We have their fx. We have 16 1600. Partial of u over partial of s for 5. And then your fy. And then your partial of v over partial of s. Now for your fx, that is 2 here. Then this one is your 4, 5. You just substitute it there in your partial of u over partial of s. You substitute 4 there, which is this one, right? This is t squared. So you can only substitute t here, which is 4. And you have here 4 cubed times 5 for your partial of v or partial of s. So it's here. 2 times 4 cube over times 5, and it's equal to 640. So substitute it here in your equations. You have there, this one is 2, this one is negative 16, this one is 3, and then this one is 640. Then when you calculate them, the total is 1888. And the answer is letter B. So who got the answer letter B there? Was the first one who answered B? No one? No one answered it. What's happening? Okay, next question. Why you didn't write your answers there? Next, we have this one. Let P be the tangent plane to the paraboloid z is equal to 4x squared plus 3y squared minus 2 at the point M1 to 14. Which point from the following belongs to P? Okay, so I will not give you your 5 minutes now. I will just explain this to you because the time it's 3:41 already. So what are you going to do here, class, is this is tangent plane. Your P is tangent plane. Which point from the following belongs to P? And you have there an M point. Okay. So first, Z at 1, 2. You substitute Z there at 1, 2. And we can solve the value of the Z is 14. So M114, which is correct here. But there's no need for you to do that step. Next, you have this equation. Find the equation of the tangent plane. The equation of the tangent plane is this one, z minus z sub o is equal to fx x sub o y sub o, x minus x sub o, and then fy x sub o y sub o times y minus y sub o here. So first we need the fx and the fy. So if this is your f of xy, our fx here is 8x. Now you substitute the 1, 2 there, we got 8. Now your fy here is 6y. Now substitute 1 and 2 there, your fy is 12. And you will substitute it there. You have your 8 and 12, that values. So z minus your z sub o there is 14. In the point there, class, you have there 1 and 2. Your 1 there is the x sub o, your 2 is the y sub o, and 14 is your z sub o. And you substitute it there in the formulas you need it, and your fx and fy. You have this one and substitute it here, then we solve. Transfer the 14 there to the other side. Okay. And you can solve this z here now. This is now the equation of the tangent plane. Z is equal to 8x plus 12y minus 18. Now, you have there four points in the given. When you substitute there 1 and 2, let's try if the answer is 19 and 16. You have to do it like this. Your x is class, no need for you to get a number from the other points. So just test the points here in your choices. You have your 1, 2, 16. So your x here is 1, your y is 2. And we try it there in our tangent equation. You have this one. If your x here is 1 and your y there is 2, so you have there 8 times 1 plus 12 times 2, that's 24, then minus that with 18. So the answer is 14. And z is equal to 14 is not there. The z partner in the choices are 16 and 19, so they are not correct. Now you try the 6, 5 points because the other choices here are 6 and 5. So you substitute it there in your z. Now this is now your equation of tangent plane. 6 and 5. So 8 times 6 plus 12 times 5. Then minus it with 18. The answer is 90. So if you have there 6 and 5, the answer is 90. So we have to pick letter D. D is there, 6590. So the answer is letter D. The 6585 is wrong. Okay, the Z that we can solve should be 90. And it's your letter D. And now next we have this one. Let Z of xy is be a function defined implicitly from the equation. Okay, now find partial of Z with respect to Y. If there's 0, 1. So your X value is 0, your Y is 1. Class, now take the derivative of that um, equation implicitly, and you can solve it like this. We have there 6xz. Okay, again, if you take the derivative with respect to z, you have to multiply it with zy. Okay, or partial of z with respect to y there, or partial of z over partial of y, it's the same. Next, you have this 4xz plus 4xy. Zy there is equal to 5z to the fourth zy plus 4xzy. Now we have this point there, 0, 1 in your x and y. So we substitute there 0 for your x and your y is 1. So that we substitute it in our original equation, which is this one, so that we can solve the value of the z. Because in this equation there, as you can see, there are some z's there. For xz, we have here z to the fourth, and this one xz also. So we need the value of the z there. So we only have the value of the x and y, which is 0 and 1. So we need this equation here. substitute here the 0 and 1, you can get the z. And what will happen? This is now 0, 0, 0. So we have there z to the fifth plus 1. Now transfer the 1 to the other side, it becomes negative 1. Take the fifth root of that. The fifth root of negative 1 is negative 1. So your z value is negative 1. But class, if you substitute now your 0, 1, and negative 1 here, there's, yeah, it's here. Your x now is 0, your y is 1, and your z is negative 1. So here, class, there's an x here, which is 0. This one is 0. For xz is 0. For xy, there's an x here also, so this is 0. Okay, here also there is a x here that you can multiply, but your x there is 0, so this term becomes 0. And your z to the, your z is negative 1, so z to the power of 4, you have there 1, because negative 1 to the power of 4 is positive 1, so you have there 5zy. Again, we are going to solve the zy value, right? So divide 5 both sides, your zy is equal to 0. So this is actually your partial of z over partial of y, and we have 0 as the answer. So the answer here is letter D. Okay, and that's it. So next we are going to start our review with this question, number 9. Okay, that's it. It's time already. It's 3:49. Okay. Um, maybe I can finish reviewing all the questions next meeting. We have 3 hours next meeting, right? So maybe at first part, I will just give you some 5 minutes there. But if we have no more enough time, I will not give you your 5 minute, what you call this, 5 minutes for you to answer it. All you have to do is I will explain how to answer them. Okay, again, if we still have lots of time, I can give you 5 minutes for you to answer. And if not, I will just discuss everything there. So I will discuss like um, the previous exams questions, like from 2023 to 2024. Okay, and that's it. And thank you for listening. Next week we will study in class, right? For next week, I will just give you slides for you to study also. Yeah, because next week only materials will be uploaded in your LMS, and you have to study those materials. Again, if you want me to discuss during that week, if you request it to me, it's fine. I can give you my time there. Okay? And then I will ask also the chairman if I am allowed to to give you some reviews there. Okay? Because I think I'm allowed. Yeah, because we're still online, right? So literally we're not in class. So it's okay maybe if we have an online something next week. Okay? I'll just announce it if we are allowed to do that. So for next week, if we still have if we still allowed to do that, I can still give you some questions and then review it to you or explain everything there. Okay? And that's it. Thank you for joining today.